Welcome back to our third and final review for Algebra 2 Spring Semester Review Exam Review. I've picked a few problems from the last set of problems that there is to go over with you. First, describing the transformation. So remember, that's our description, our verbal descriptions of how our absolute value parent function transforms. Remember, our absolute value parent function that we talked about in the last session is y equals the absolute value of x. So all they're looking for is how does these things that are attached to our parent function change the look of the graph. Remember, anything that's to the front will affect it vertically, and since it's a negative, it's going to give it a reflection across the x-axis. So instead of our graph pointing up like this, like it normally does, it's going to be reflected over the x-axis, and it should be pointing down. Remember, you can plug that into your calculator and make sure that those are the things that happen to it. The other thing that affects our graph would be this 5 that's inside our parentheses, or our absolute value bars. And remember, inside, if it's attached to the x, we'd like to say that it does opposite what we expect it to do. So it's going to be a horizontal shift, although instead of going to the left 5 like you naturally would think, we do the opposite. So it's going to be a horizontal shift to the right 5. Units. And similar to that, we have added on the end of it our -10, which is also going to affect it vertically. Notice the vertical things are the things to the outside or around the absolute value. The horizontal things are the things that are inside it. So it will be a vertical a vertical shift. But when we're talking vertically, we follow the sign that's here. So typically a minus or a negative would be a downward motion. So we would say it's a vertical shift 10 units down, or down 10 units, however you want to write it. Either way is fine. Remember, you can go to your calculator, and I'm going to open me up a graph screen so that you can see the screen. And if I type this in as is, it would be a negative. And then my absolute value, if you forgot where that is, or you have trouble finding it, your template key over here next to the 9, you have absolute value bars right here. So you can arrow over and get the absolute value bar and push enter. And then inside my absolute value bar, I want an x minus 5. Make sure you arrow to the outside of your absolute value bars. To the outside, and we're going to have our -10. And when we do that, it goes off of the graph, but you can see that it moved down. We can change our view by doing the window zoom, or the 4. You can just push the 4 key. We could simply zoom out. A lot of times students feel like that's the easiest thing to do, is to continue to just zoom out, zoom out, zoom out. But notice it's not going, we're only at -6 here. So sometimes the faster thing to do on that zoom is to go down to where did it go? Let's do a zoom fit, because a lot of times, there it goes, it will fit it in so that we can see it, and see that it goes down like we expected it to. That's the flip over the x-axis. Notice it's moved to the right, and then we obviously are moved down, because notice this number down here is now a -26.5. So we've moved down quite a bit. You can also see there's a -10 over here. Okay, so your transformations are just simply how did the graph move, and so we're giving it a verbal description. Okay, now on number 49, this time they want us to write the equation, and they gave us the vertical the verbal description. So they're telling us that it's going to be a square root parent function, which remember our square root parent function is y equals the square root of x. And they're telling us it's going to be translated 3 units to the left. So remember, we talked about that left being where it's inside attached to the x value. So because we have this 3 units to the left, left meaning a negative direction, we know we want to put a plus because what's inside attached to it is going to be opposite of what we expect. So that would be a +3. They also tell us that it reflects over the x-axis, which remember that reflecting over the x-axis we just said means it's going to be a negative. Now this one is a little different. It talks about vertically having a compression of a factor of a half. So remember, vertical means it's everything that happens outside the function or to the y values. So since it's compressed by a factor of 1/2, it's going to be multiplied by a 1/2 here. If it said it was stretched by a factor of 3, it would have just a number 3 up in the front. So that way you can determine which one is which. Okay? Now, our domain and range, hopefully you've gotten a lot better with your domain and range so that you can write in different sorts of notations, set notation as well as interval. This gives you an opportunity to do both. They want us to write our set notation for our domain and range of this function. So our domain, remember, are x values, and our x values go left to right. So all we need to do is think about if this was on a train track, and our train was going to the left because it's set notation. Notice it goes forever and ever and ever, and to the right it goes forever and ever and ever as well. So we simply say for set notation, those are x values such that, and we say x, and this little symbol means is in the set of, and this little symbol means all real numbers. You could write out all real numbers if you wanted to, but that's our sort of math shortcut, shorthand, if you will, because we don't like to write things out any more than we have to. Now our range, remember, are our y values, so we're going to be looking up and down. So also think about that train. It would be going forever and ever down, and it would be going forever and ever up, but because it's range and it's y, that's going to be the y values, such that y is in the set of all real numbers. When we do interval notation, remember that's the even more of a shortcut sometimes for us. Domain again is left to right. So if you think about left to right, how far does it go left? Well, it goes to this point right here. Notice it's filled in, which means x values, the x value that it crosses is 1. So it goes from 1 and it's continuous all the way to this point, which this x value is 5. So we write that it goes from 1 to 5. Whoops, that's supposed to be a 5. 1 to 5. And they're square brackets because they're both included, or they're both filled in circles. If one of them was open, it would be a rounded bracket. Now, our range, on the other hand, we're going up and down. We're looking at how far the graph goes down, how far the graph goes up. So notice our graph, the highest it goes is here, and the lowest it goes is here, looking on our y-axis. So the lowest number is 0, the highest number is 3. So it would go from 0 to 3. Again, they're round filled in circles, so they would be both square brackets. Okay. Now, to multiply with our rational expressions, we're looking for factors of everything, and anything that we can reduce top with anything on the bottom can be reduced. For example, I know that 4 divides into 8, so I could say 4 goes into 8 2 times. The only thing I caution you with a lot of this is make sure you stay neat. At any time you feel like it's getting too crowded or too jumbled, you can't read it, rewrite the stuff you have left over and then do it again. We can also reduce our 10 and our 6 because 2 goes into 6 3 times and 2 goes into 10 5 times. So notice with my numbers, I could go ahead and rewrite it now if I wanted to, And that would give me 10 on the top, and that would give me 3 on the bottom. And I could go ahead and do my multiplication with my variables because that's not that hard. Remember, with our multiplying, we're going to add our exponents. So my x squared plus my x to the 1 is going to give me an x to the third. 2 plus 1 gives me 3. And then same thing with my y's. My y to the third and my y would give me a y to the fourth. And then I have a z on the top. On the bottom, I still have a 1y and I have a z squared. And then you could easily tell that with my y's, I could reduce these and be left with just a y to the third on the top. And then the same thing with my z's. I have 1 on the top and 2 on the bottom, so I'm going to be left with a z on the bottom for a final answer of 10x to the third, y to the third over 3z. And that would be your simplified version. Okay, so with number 61, again we're multiplying. Again, we've got rational exponents with our multiplying. Notice my bases are the same. We talked earlier, we know when we're multiplying with exponents, we're simply adding our exponents. So we keep that same base, and I'm going to be doing 1/3 plus 2/3, which gives me 3/3, and 3 over 3 is simply 1. So the simplified version of that is just 64. And you have several examples for you to practice doing that as well. Now, to write your factors, remember factors are things that are multiplied together. And when we already know what our given zeros are, they've given us our zeros, you can think of this as they've given you that x is equal to 3, x is equal to -7, and x is equal to 2. Now, if you were to work backwards, thinking about where these problems came from, or where these roots or zeros came from, you could move your 3 back over by subtracting 3 to both sides, and notice the step prior to that would have been x minus 3 equals 0. Likewise, if I move my 7 over, that would be x plus 7 is equal to 0. And similarly, if I move my 2 over, that would be x minus 2 is equal to 0. Therefore, these are our factors, one being x minus 3, and one being x plus 7, and lastly, x minus 2. Those are your 3 factors. Now, with our composites, with composite functions, remember FOG, it looked like the fog. If it says FOG of x, that is the same as saying f of g of x. I like this form better because it helps me to see that I'm taking one function and plugging it into the other. So what I want to do is I want to take this g of x, which is x plus 1, and I'm going to put it in place of this g of x right here. So my function was f of, and in place of g of x, I will be putting 3x plus 1. Well, notice my f function is x minus 5. So f would be x minus 5. And what I'm going to do is I'm going to take that g of x and put it in place of that, where the x was. And then we just sort of clean it up. So when we clean that up, 3x plus 1 minus 5 gives me 3x minus 4. And you're just plugging it in. They will give you a few of your functions. You will have just different things that you have to do with that. Okay? All right, now finding the inverse when they give us a table, remember we're just going to bring it back out with another table. And all we do is switch our signs. So what was in the y column, I'm going to be writing in the x column, and what was in the x column goes in the y column. And that will give me my inverse, which remember graphs by reflecting over the y equals x line. But that's a super simple way to find your inverse if you're given a table. Okay? So it looks like I will have to do one more lesson so that if y'all need to tune in, you can catch the next one. Thanks.